This is Mr. Anderson for Math 121, Intermediate Algebra. We are going to be looking at Section 2 of Chapter 7. We're looking at rational numbers as exponents. Now, the basic rule here is that if you have a radical, and that radical, like the square root of x, which has an index of 2 here, you can rewrite that as a fractional exponent, or x to the 1/2 power. This is also true for higher indexes, like let's say we have the fourth root of x, which is going to be x to the 1/4 power. And also this works if we have a base that has a power inside, like let's say this is the fourth. So x to the fourth under the radical of the ninth root. This gives us x to the 4/9. So our denominator is going to be the index, and our numerator is going to be the power assigned to the variable. So if you want to see this in general terms, if we have the bth root of x to the a, this will give you x to the a over b power. So to kind of see that in action, we're going to take the cubic root of x here. We're going to take the fourth root of 81, which we can type in on the calculator and get the answer of 3, and I'll do a little bit of work on that when we get to number 5. This is going to be the fifth root of xy, that quantity since it was in parentheses. This is going to be the cubic root of x squared. Notice that the x cannot get out because it has a power less than the cubic root, which will be explained in the next section. And also I want to talk a little bit about 9 to the 5/2. This can be written as the square root of 9 to the 5th power. Now there's a couple ways you can do this. Let's take a look at the graphing calculator and do a focus on problems 2 and 5. Now if you're wondering how do I take the fourth root of 81, click the 4 key and then go to your math and choose the option 5, which gives us that index of an x. So this would be the fourth root of, and I can put this in parentheses, 81. Newer calculators will have the parentheses already there for you, and that'll get you that answer of 3. Of course, you can do this too. You can put the caret key and raise that to the 1/4 power, and I like putting these in parentheses so there's no mistakes. You could also put 0.25 in there, and that gives you the same answer. So using the same kind of shortcut, I will take 9 and raise it to the 2.5 power, or 5 divided by 2, and that gives you 243. A couple other things too. I could have raised 3 to the 5th power and received the same answer, but again, more of these tricks will be given later. So let's go put the calc away for a moment, and actually I think I probably should use it here. 9 to the 3/2 power, I'll probably compute that right now, since we can split this into two through the power rules here of multiplication. We can use 9 to the 3/2 power, or 1.5 power, and get our answer of 27. And 6 to the 3/2 power, we can use our multiplication skills using powers, and I'll show you here. We can, since we know 9 to the 3/2 is 27, I'm going to put that over here by my final answer. But let's just focus on the x to the 6th raised to the 3/2 power. Using our powers of multiplication, since this is a power to a power rule, this is 6 times 3, which is 18, divided by 2, so this is x to the 9th. So if you wanted to see this written in another way, this is like saying I'm going to take the square root of x times x raised to the 6 times 3, or the square root of x to the 18, and 18 divided by 2 is 9. Again, more of these little tricks are going to be shown tomorrow. So let me move the calc out of the way and just show a little bit of work in manipulating some of these expressions here. We're going to write an equivalent expression using the exponential notation. So here they're just looking for some quick edits. So when we look at the square root of 22, that's like saying 22 raised to the 1/2 power. Now, is this going to be x to the 4/5 power or the 5/4 power? It would be 4/5, because the index is 5 and the power associated with the variables on top. Now when we move to problem 9, we're going to see this is x to the 4/6. This is y, and z to the 7/6. Now we're going to do some simplification because 4/6 can be reduced to 2/3. So we're going to have this as x to the 2/3 power. This is going to be y, and for today you might just leave this as 7/6, but as we see tomorrow, we're going to leave this as z and z to the 1/6 power, because that's 1 and 1/6. 7/6 is 1 and 1/6, so this is how we're going to split this up starting tomorrow, because this will be the 6th root of z, and this will be the cubic root of x squared. But again, more to show you tomorrow. In the negative exponents, the negative exponent changes the numerator to the denominator to the numerator, or it flips the fraction. In this case, this x is going to move from numerator to the denominator with the power, but now the power is going to be positive. This is a review of the negative exponent rules. Taking a look at 11, the negative exponent is going to move from numerator to denominator to numerator, or it flips the fraction. In this case, it flips the fraction from 1/8 to 8/1 and makes this 2/3 instead of negative 2/3. Now, if you look at 12 and 13, most people get these two confused because they believe that the way that 12 should be written is the same way that 13 should be written. But in fact, the negative exponent only has a grasp of the y and not the 5x. So the 5x would stay in the numerator and the y would go to the denominator and turn positive. Whereas in number 13, what most people think number 12 is saying is that the entire quantity would move to the denominator and 2/3 would stay and would then turn positive in that corner. And like number 11 and 14, these are fractions that get flipped on its head because of the parentheses gripping the entire fraction, and we can't drop the parentheses because that whole thing is still getting raised to the 3/5 power. Now, if we had time, we would go through and show you how we could do a little bit of simplification with this, but that's really not the goal of this part of the worksheet. And for our final part of the worksheet, we're going to use some laws of exponents to simplify. Now, this kind of channels a little bit back to some of the work we were doing before. This is x to the 40th power, but this is raised to the 1/4 power. Now, obviously, you've seen this as one of our rules from the very start, where this is 40 divided by 4. But you can see where the power to power rule is being applied. 40 times 1 and 1 times 4 is 40/4, or this simplifies to x to the 10th power. This, inside the parentheses, can be written as xy raised to the 1/3 power. But then the whole thing is raised to the 15th power. And since this is a power to power rule, 1 times 15 is 15 divided by 3, this becomes xy raised to just the 5th power, because 15 divided by 3 is 5. Now this one's a little tricky because we have 5x inside its own protective shield of 1/3, which is inside of another shield raised to the 1/5. So the power to power rule means we multiply top times top, bottom times bottom, so 5x is equal to, or 5x with the fraction in the corner of 1/15. Sorry, that is written a little bad. Let me rewrite it. This is 5x to the 1/15th power. All right. Well, thanks for watching today.